Our third lesson in this series is looking at polynomial equations and continuing to factor. If we take a quick look at an example that we were shown in the first exercise, it represents the volume of an equation for an ice block that a sculptor might be carving. X in this case represents the thickness of the block and V is the volume. Later on we are going to take a look at working through a solution where a set volume is chosen and we are going to try and find the maximum thickness of wings that can be carved from a block of ice. And we can do this by factoring. Recall, for example, in the last unit that we found when factoring polynomial functions we are able to identify the zeros of the function and in turn represent and identify the x-intercepts. This is helpful in sketching or in graphing. For a polynomial function y equals p at x, the roots are determined by letting y equal 0. That doesn't change. That's always been the case. If the polynomial equation is factorable, then the values of the roots can be determined algebraically by solving each linear or quadratic factor. So if you were to recognize or find through long division that x minus 1 is a factor of a larger polynomial and you ended up with a quadratic, let's make that minus 2, then you could factor that quadratic one more step to become x plus 2 x minus 1. What we're going to review today is some factoring techniques that you've practiced many times before. When asked to solve the question, you are going to go through a process of trying to factor your polynomial and then eventually set the y value, which already in this case is set to 0. And so the very first thing that we always look for when we are factoring is to see, in fact, if there is a common factor. And in this particular case, we notice an x located in each of the terms on the left-hand side. So a great first step is always to look for a common factor. Once you have that common factor, you can now look at what's left over and see if that trinomial is factorable. And in our particular case, it is. By writing the equation in factored form, we can not only identify the factors, but also the x-intercepts. So the graph crosses the x-axis at 0, don't forget about the x out in front, positive 2, and negative 1. Our second example has 4 terms on the left-hand side. 1, 2, 3, 4. This is a special type of polynomial. We do once again look for common factoring, but we don't see any. So because there are 4 terms here, or an even number, maybe we can use the technique of graphing or grouping. And what grouping allows us to do is to look at these on a smaller scale. I do notice that I can factor out an x squared from the first 2 terms, and it's like you're dividing each of the first 2 terms by x squared, so I'm left with 3x plus 1. And the last 2 terms, I can factor out a negative 4 from both of these. If I factor out that negative 4, I end up with 3x plus 1. When these 2 factor terms are left over, we can then factor these out from the front of the equation, or in the front of the equation. So I notice I have a 3x plus 1 here and a 3x plus 1 here. What I can do is factor a 3x plus 1 out of both terms, and what I'm left with is an x squared subtract 4. So it's like you're dividing both first term and second term by 3x plus 1. We do notice that we can go one step further to help solve this question, and that is we notice this is a difference of perfect squares, x plus 2, x minus 2. If all it asked us to do was a factor, we'd be finished. But because it said solve, we need to set each of these x-intercepts to 0. So once again, 3x plus 1 is equal to 0, 3x is equal to negative 1, and finally x is equal to negative 1 over 3. The remaining two, x equals negative 2 and x equals positive 2, round out our final two factors. So when we're looking at these three factors, the equation is solved by stating that x is equal to negative 1 over 3, negative 2, and positive 2. This is called factoring by grouping. And we use that sort of imaginary line tool that allows us to group these and look at them individually. Now let's take a look at a polynomial question